Okay, so we're on lesson 117. There's almost no content in your blue book here. Most of the content comes out of EWR. We are looking at 3 chapters this time. They're all 3 pretty small, but that's 10, 11, and 12 in your EWR book. And again, with 3 chapters, it's kind of a hodgepodge of information and material. So I'm going to go through some of the lighter stuff from chapters 10 and 11, and then we get into chapter 12. We get into small appliance circuit requirements, which that's your kitchen counter outlets, things like that. The first thing they mention is they give you sort of this tip here on roughing in for a bathroom vanity. In this first instance here, we're actually putting a box in the wall. In this instance, they're actually not putting a box, and usually the drywaller is actually going to bury that wire. This is a little bit of a gamble, but it's a good tip. If you don't know exactly where the center of that bath vanity is going to be, or exactly where your light has to rough in, you can tell at least which stud bay you should be in and leave it in there. Cut a box in later after the vanity and the sink has been set. Next one, they're going to talk about how many receptacle outlets we need in a hallway, a residential hallway again. The rule states any hallway that is 10 foot or less, we don't need any outlets. As soon as we hit 10 foot or greater, we need at least 1. So that's 1 outlet. If it's 10 foot, 20 foot, 100 foot, 1 is the minimum. They're never going to tell you you have to do more than 1. Of course, you always can. We know the NEC is code minimum, of course. The next idea that they throw at us is where can we put light fixtures in a bathroom? Okay. So they kind of give us this zone around a tub or a shower, and that's 3 foot to either side all the way around, and 8 foot tall from the top of the tub. So in this case, the top of the tub is, a foot or 2 up off the ground. In this case, it's a sunken tub like a jacuzzi tub. Either way, you're going to measure 8 foot from the top of the tub. Within that area, no suspended luminaires are permitted. We can't be in here with it. We can't be in here. We'd have to be outside that zone, right? We can do surface or recessed within that zone, which you do see this quite a bit. Recessed lights are popular. A recessed exhaust fan is even popular. However, even in that area, if it's subject to direct spray, we need to have rated for wet locations. And if it's within the actual footprint of the tub or shower itself, so in this area, we need to at the very least be damp location rated. And this is a good time to talk about the difference between wet location and damp location. This isn't exactly a hard rule, but I think it's a really good one to go by. And they measure from the edge of your cover at a 45-degree angle. If you're above that, you're in your damp location. If you're below, you're in your wet location. Again, not a firm rule, but a pretty good rule of thumb to start with. Okay, next they're talking about a post light, a residential post light. The thing I want to point out here is they give us 2 options on how we can penetrate and get that from underground into the house. The first one, they actually make the penetration underground. The second one, we're coming up and making a penetration above ground, because usually your basement sticks up above finished grade a foot or 2. I personally really like that second method because waterproofing that penetration is a lot easier as compared to waterproofing that penetration. We do talk about clock receptacles. I'm just throwing this up there so you guys can get an idea. It wires up just like a regular receptacle, but it's actually got this little recessed part. You could plug something in here, the cord would be recessed, and this one actually has a little hook there as well. And as the name implies, it's to hang a powered clock there. You don't see this very often anymore, but they do talk about this. So I want you to have an idea of what that looks like, a clock receptacle. So now we're kind of on to the real the big idea in these 3 chapters, and that's our small appliance branch circuits. So in layman's terms, that's just your kitchen counter receptacle circuits, right? But the code's going to reference it as small appliance branch circuits. Okay. So first off, and you might have heard some of these already, but they're very important. We need a minimum of 2 small appliance branch circuits to the kitchen. Minimum. Gotta have it. They gotta be rated 20 amps. And the reason for both those rules, obviously a lot of our kitchen appliances have a heavy draw to them. They draw a lot of amps. We can actually serve dining room, breakfast room, or pantry with these same circuits. I don't recommend it, but you are permitted to do that. I don't think I've ever seen anybody do that. When we do our service load calculations at the end, towards the end of the year, we have to count each of those circuits at 1500 volt amps in the total service load. More on that later, just put a pin in that one. We do have to be GFCI, and I believe they added that in 2018, AFCI protected as well for this circuit. We used to not have to have AFCI protection. As of 2018, now we need both. Okay, we can serve a gas appliance with this same circuit or one of these circuits, and really we're talking about the gas range. Obviously that's a low draw, it just needs some very minimal power to it. So we can serve a gas appliance with this circuit. However, we can't serve lighting or other permanently connected appliances. So I think they specifically tell you a dishwasher, a garbage disposal, can't do that. If they're permanently connected, we need its own circuit. Our small appliance circuits are for portable loads only. So it's a good time to talk about the refrigerator specifically. If you ever had an issue with breakers tripping in a home, it's a lot of times because the fridge is on the same circuit as something else. This kind of trip you up a little bit though. The fridge, the NEC says it is permitted to be on one of our small appliance branch circuits. So the NEC says, yeah, that's okay. And you can check that. It's a 210.52b1. However, it's also permitted to be on a separate circuit and also highly recommended. And it's funny the way they write that, because it's actually an exception to 210.52b1 that allows it to be on a different circuit. Again, that's highly recommended. The code has a really funny way of wording that. However, we also must follow the manufacturer's instructions. It might list in that refrigerator literature it's got to be on a dedicated circuit anyway. Bottom line, we've got to make sure we're meeting their listed install instructions. So a little bit more on our kitchen counter receptacles, small appliance receptacles. No countertop or wall space can be more than 24 inches from a receptacle. In other words, the 4-foot rule. So our receptacles must be no more than 4 foot apart. It's just like our 6-foot, 12-foot rule in every other area of the house, but in this case it's a 24-inch or 4-foot rule instead. So receptacles maximum of 4 feet apart along the counter. Any countertop or wall space that's 12 inches or more must have a receptacle. If we're less than that, we don't need a receptacle. And we should mention what counts as a wall space above a counter. Literally as the name implies, any wall space above the counter. But the range, the sink, things like that tend to break up the wall spaces. So you'd come 2 foot out from your sink, put your first receptacle, go another 4 foot, hit your second, so on and so forth. We can install these face up in the counter. That's obviously if something spills, it's going right down in there. No more than 20 foot above the counter. They must be no more than 20 inches above the counter, and usually they're only a few inches. 20 inches is pretty high. You're almost getting to your base cabinets at that point, or your wall cabinets, I should say. We can't be below the countertop unless there's a couple reasons why we might have to be. If it needs to be handicap accessible, that's got its own set of rules. If there's no wall space above, we still need to put our receptacles where we're going to put them. Well, we're kind of running out of room, we've got to do below. So maybe a peninsula you could think of. And we can't put it below where there's an area meant for seating, like a bar top seating. And the code actually says if the counter extends 6 inches beyond the cabinet, that's considered for seating. We can't put receptacles there. People sit there, kick and pull on things. Speaking of peninsulas and islands, any peninsula or island that's 12 inches by 24 inches or greater must also now have receptacles added to it. And again, you're always going to see these in the base cabinet because there usually is no wall space to put a receptacle in. Ranges and sinks less than 12 inches from the wall behind them will create separate spaces. Again, how do you know what your space starts and ends? Well, a range or a sink might start or end a space. Permanently installed hanging microwaves require a separate circuit. So the ones that maybe hang above a stove, something like that. Again, if it's for a specific piece of equipment, it's got to have its own circuit. The small appliance branch circuits are for portable equipment only. Wall space behind an appliance is 12 inches or more from the wall. That still counts as wall space. So your book gives you an example where the sink for some reason is more than 12 inches from the wall. That doesn't actually break up the wall space. We need to keep that 4-foot spacing going beyond that. And then we sort of have the same rule if you have a corner mounted sink, something like that. Go from the corner out to the edge of the sink. If it's 18 inches or more, that doesn't break up the wall space. So again, your 4-foot spacing needs to continue through there. Alright, so that was a lot of information. The book's got some great diagrams, things like that. Spend some time, really read through that, think about what I've just told you, and put them all together.